Assalamu alaikum. ازيكم يا ولاد? How are you everybody? Today we are going to explain a theorem that we didn't study the last year and we need it so much this year. This theorem is called Euclidean theorem. Euclidean theorem is talking about right-angled triangle. The right-angled triangle ABC, which is right-angled at A, and we must have an altitude from the right angle, which is AD, is perpendicular on the hypotenuse BC. Again, we have a right-angled triangle ABC, right-angled at A, and we have an altitude which is perpendicular on the hypotenuse, as the figure shown. We have three rules from this theorem. We have to know it well to use it for so much problems. At the first, we have to remember that AD and AC are the two legs or the two right sides in the right-angled triangle. BC is the hypotenuse and AD is perpendicular on BC. As we see in the figure, we have three right-angled triangles. The big one, which is ABC, the small right one is ABD, and the small left one ABC. We can use the Pythagoras theorem in each of these three triangles. And also, we have to know the rules of the Euclidean theorem. What are the rules which we are going to study? The first one is the first right side, which is AB. AB is the right side. The right side power 2 equals the hypotenuse, which is BC, times the part of the hypotenuse beside the right side. Again, we are going to say that AB power 2 equals BC, which is the hypotenuse, times BD, the part of the hypotenuse beside AB, as the second side, AC power 2 or CA power 2. It is the second right side. The second right side, which is AC power 2, equals the same, the hypotenuse times the part of the side next or near to this side, which is called projection, and we don't need this projection now. AC power 2 equals CD times CD. Okay? So the two rules are talking about the right side power 2 equal the multiplication of the hypotenuse times the part of the hypotenuse beside the side. The third rule is AD power 2, which is the altitude. The altitude power 2 equals the two parts of the hypotenuse. What are the two parts of the hypotenuse? BD and CD. So AD power 2 equal BD times CD. We have an example now to apply this theorem on an example. We have the triangle DEF, which is right angled at the D, and DN is perpendicular on FE, and only we have the two parts NE and FN, which are the two parts of the hypotenuse. So we can use that all the hypotenuse equals 16 plus 9, so FE equals 25. The example need to know what is the length of DE, what is the length of DF, and what's the length of DN. At first we see the example. The figure we have DE is right side, so DE power 2, as the rule of Euclidean, said that DE power 2 equals NE times all FE, which is the hypotenuse. So DE power 2 equals EN, which is 9, times EF, which is 25. So the result will get its square root to find DE. DE will equal 15, but if we calculate 9 times 25, it will be 225. So we get its square root and find DE, which is 15. The other requirement, DF power 2 equals FN times all the hypotenuse, which is FE. So df power 2 equals 16 times 25, so it becomes 400, and we get its square root, so df equals 20 centimeters. The last one, he needs dn. dn power 2 equals ne times fn. As we said before, the altitude power 2 equals the multiplication of the two parts of the hypotenuse. So dn power 2 equals 9 times 16 equals 144, and we get its square root and find it 12 centimeters.